Hello, my name is Laquela Roberts, and I will be teaching Module 3, Chapter 4, Number Theory, and Chapter 5, Integers. I hope you enjoy. Let's get started. All right, as you see, question 1 is use the divisibility to decide which of the numbers 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 is a divisor of the numbers in the left column of the following table. The number 684 is done for you. Well, as you can see, what we will do here on this question is we will divide 684 into 2. Yes. 684 into 3. Yes. 684 into 4. Yes. 685. 4 into 5. Sorry. Nope, it won't divide easy. 684 into 6, yes. 684 into 7, no. Into 8, no. Into 9, yes. Into 10, no. And into 11, no. So what you would do here is you would do the same thing as the first example I just showed. You're dividing it by those numbers to the left to see if they are divisible by the number, okay? Question 2, demonstrate the processes of nines to check each of the following answers. So the first one is, it gave us 416 plus 7,490 plus 69,844, and that totaled up to 112,790. Let's see if that's true or not. All right, so what we got here is 4 plus 1 plus 6 equals 11, with the remainder 2. So we got the number up here, all right? And then we have 7 plus 4 plus 9 plus 0 equals 20 with the remainder 2. Then we got 6 plus 9 plus 8 plus 4 equals 31 with the remainder of 4. So we have 2 plus 2 plus 4 equals 8. And so we have 1 plus 1 plus 2 plus 7 plus 9 plus 0 equals 20 with the remainder of 2. So guess what? That equation is incorrect. So to find the right equation, you're going to add 416, 7,490, 69,844. So you will get 77,750. That is the correct equation. On to the next one. B. All right. So we have our numbers at the top, 8550 plus 6888 plus 2525 plus 6029 gives us 23,892. Do you think that's correct? I don't know either. Let's find out. All right, so we're going to add 8 plus 5 plus 5 plus 0 equals 18 with the remainder of 2. 6 plus 8 plus 8 plus 8 equals 30 with the remainder of 3. 2 plus 5 plus 2 plus 5 is 14 with the remainder of 5. 6 plus 0 plus 2 plus 9 equals 17 with the remainder of 8. And then we have 3 plus 5 plus 8 gives us 16. And then we have next the 2 plus 3 plus 8 plus 9 plus 2 equals 24 with the remainder of 6. So this equation is incorrect. So to find the right equation to come out right, you're going to add 8,055, 8,550, 6,888, 2,525, 6,029, and that's going to give us a total of 23,992. C. We have a subtraction. So we're going to subtract 78,362 minus 3,674, which is saying is giving us 74,678. I don't know. Let's see. 7 plus 8 plus 3 plus 6 plus 2 equals 26, remainder of 8. 3 plus 6 plus 7 plus 4 equals 20, remainder of 2. 8 plus 2 equals 10. with the remainder of 1. 7 plus 4 plus 6 plus 7 plus 8 equals 32, remainder of 5. So that equation is saying it's incorrect, okay? So 78,362 minus 3,674, and it does give us 74,678. So it's correct. All right, here's our multiplication. So 337 times 620 equals 209, 940. We're going to multiply 3 times 7 gives us 63 with the remainder of 21. 6 times 2 times 0 equals 0, remainder of 0. So that equation is not right. So what you'll do is going to multiply 337 times 620, and that's going to give us 208,000, and 940. So this is the one is correct. Show which rods will measure the non-rod. Question 3. So as you see, we have our rods on the right side, and they're numbered 1 through 6 in different colors. So the factors of 9 will be 1, 3, or 9, because 1 times 9 is 9, 3 times 3 is 9. So 1, 3, and 9 rods can be used to measure the 9. So which rods will measure the 6 rod? As you see, we have our rods to the right, and our factors of 6 includes 1, 2, and 3, and 6, because 1 times 6 is 6, 2 times 3 is 6. So as you can see, so the 1, 2, and 3, and 6 rods can be used to measure 6. Use parts A and B to show the greatest common divisor of 9 and 6. Well, let's look. So we know the factor of 9 is 1, 3, and 9. We know our factors of 6 is 1, 2, 3, and 6. So that means our greatest common divisor is 3, because 9 can go into 3 and 9 can go to 6. Place the 10 rod in the 8 rod end to form an 18 train. So all rods or trains will measure the 18 train. So as you see here, we have the factors of 18, which includes 1 times 18, 2 times 9, 3 times 6, and they all give us 18. So we will use 1, 2, 3, 6, 9, and 18 rods can be used to measure the 18. Demonstrate how you might use these colored rods to demonstrate the notion of greatest common divisor to children. So it is observed that the rods that can measure an N rod form the divisors of N. Also, the rods that can measure an M rod, and also an N rod for the common divisor of M and N, with the rod having the greatest length forming the greatest common divisor of M and N, or greatest common divisor MN. Demonstrate the use of the method to find the lowest common multiples in parts A through C in prime power form. So question 4A gives us the lowest common multiple, 48, 25, and 65. We have our table here with our numbers. So we would do 48 divided by 2 would give us 24. 24 divided by 2 would give us 12. 12 divided by 2 would give us 6. 6 divided by 2 would give us 3. 3 divided by 3 will give us 1. And of course, 5 will give us 1. Bring that down. 25 and 2, they won't go. So you just bring the 25 down. 25 and 3, it won't go. You bring the 25 down again. 25 divided by 5 will give you 5. Same over here with 65. You bring it down because it won't go into 2 or 3. So it'll go into 5, which will give you 13. So our prime factorization there will be 2 to the 4 times 3 to the first times 5 to the second times 13 to the first. Question 4B. We have our lowest common multiples of 40, 12, 44, and 363. So we got 2 times 20, 4 times 10, and 5 times 8. For 12, 2 times 6, 3 times 4. 44, 2 times 22, 4 times 11. 363, we got 3 times 121, and 11 times 33. So our prime factorization with this will be 2 to the third times 3 to the second times 5 to the first times 11 to the first times 33 to the first. All right, so question 4C, we have our lowest common multiples of 250, 28, 44, and 110. And as you can see, 2 times 125 give us 250, 5 times 50, and 10 times 25. 28, we got 2 times 14 and 4 times 7. 44, 2 times 22 and 4 times 11. 110, 2 times 55, 5 times 22, 10 times 11 gives us 110. And our prime factorization for this problem is 2 to the 4 times 5 to the second times 7 to the first times 11 to the second times 55 to the first. All right, in a machine, a gear with 48 teeth is engaged with the gear with 84 teeth, with teeth A and B on the small and large gears. Demonstrate how many revolutions the small gear will have to make before A and B are again in the same position. Question 5. So 84 is our larger gear, 48 is our smaller gear. So gear A, which is 84, we got 168, 252, 336, 420, 504, 588, 672, 756, and 840. Gear B, which is 48, so we got 96, 144, 192, 240, 288, 336, 384, 432, and 480. So our lowest common multiple will be 336 because it's in gear A and B. So you're going to, our rotation, you would divide 336 divided by 48 will give us 7. So 7 is what it is. So the gear will make 7 rotations to end up in the starting position. Demonstrate how to create a magic square using the following integers: -7, -6, -5, -4, -3, -2, -1, 0, and also 1. All right, so as our table, you see 0 and -1 that was given to us. And we're going to add our integers, which is -7 plus -6 plus -5 plus -4 plus -3 plus -2 plus -1 plus 0 plus 1 equals -27. So you would divide -27 divided by 3 equals 9. So our magic number for this will be 9. You got your 5, -5, your -4, your -7, your -3, your 1, your -2, your -1, and your -6. Thank you so much, and I hope you will and you enjoy this. Thank you, and you have a good one. Bye.